This conference will now be recorded.
Hi, good morning, everyone. Hope you are able to see my screen as well as you are able to hear me clearly.
Yes, good morning.
Okay, good morning. So, hope all of you are in front of your computers and ready to try some snippets of code and exercise your brains as you are understanding some basics about Python. So, we'll continue from where we have left last time. Actually, in the third section of our Python crash course, we started with flows and functions. After completing the basics and also the data structures, we entered this topic, flows and functions. And in the last lesson, we tried a little bit of flow statements, especially uh, the if, the conditional logic using if, elif, else construct, not rocket science. Then we also looked into the iterative construct using for, okay, and extended that for iterative construct to understand a little bit more clever ways of building lists by transforming existing lists. We looked in the list comprehensions, and today we'll continue from where we have left. So we will briefly talk about what are these functions and why they are useful in Python, and then we will today complete this flows and functions by completing an exercise that we started with data structures. That is what is our goal for today. We will write a little bit of logic today, not very complex, but you have to apply, and maybe after the class also you will have to go study for yourself how some things are working, what is the logic behind, and as you try, you will get it. It's not really rocket science. Why I am telling it is not rocket science? If I could understand, any of you can understand it. So that is my logic about this. So let us get going with functions. So functions are basically blocks of reusable code. So while we are solving some of these machine learning problems, we do same set of actions again and again with different data or keywords, the hard coded data. Okay, so that is unnecessary waste of time. So we can convert all that into, in a very clever manner, some pieces of reusable code, so that we can save a lot of time. We can do more things by kind of having these functions at our disposal instead of unnecessarily wasting time. You will see how, because when we do our first toy project, we'll build many models with many variations of settings. Then you will realize every time you run a model, using that model, predict it and then plot it, you will be doing same operations. So instead of doing same operations, you all capture all of those things into a reusable function and pass a set of arguments, and then understand how actually models are working faster than unnecessarily keying in unnecessary code. Okay, so basically functions are blocks of reusable code. Okay, functions provide modularity for your code and make it much easier to stay organized. Okay, so that is why thinking through these functions is important. So basically, functions allow you to reuse and quickly tailor code to different situations. Okay, like if you see in this picture here, you define a function. At the time of defining the function, you think what arguments are passed to this function. Those are the inputs. Then I read them, and what should I do? You write some logic, and then you return whatever the output produced by the logic. so that anybody can use this function, call it in his or her own program by passing the right arguments and get the output relevant to those arguments. Okay, so functions are blocks of reusable code that can be called by its name. Functions even have their own type function. When you define in Python a function using its syntax and type check on that named variable function name, then it will tell it is a type function. So it's an object. A function, once you define, it is a Python object. Okay, so let us create one. So let us look at this syntax. Here I am defining a function. So to define a function, I am using def keyword. Then I am giving a name to my own function. So again, naming conventions, if you follow them well, all small letters, no capital letters, and make it very readable kind of name, so that anybody sees immediately, they know what is that it is going to do. So anywhere words are there, replace it with spaces with underscores. That is the naming convention we talked earlier. So you are naming it. Then you have an ability to pass few arguments. You may pass, may not pass, but that is in a parenthesis, you will pass the arguments. Okay. Then we end the definition with a colon, meaning there is a child block code will start. So when you tab there, it will give one tab space. So 4 spaces will be given, and then there you will write the block of code. Then your definition of function is done. Then you can call this function anywhere in your code in whichever way you need, as long as you're passing the right arguments and trying to get the right kind of output. So you may type this and get used to this syntax. One more time, let us look at it, break this. So functions begin with def keyword followed by the function name and a colon. So like in your Java and all, a lot of curly braces are there. They're all replaced by this colon and one tab space that is equivalent to those curly braces. And again, outdent back to continue with your parent lines. Okay. Functions, they can take optional arguments. They are optional. Okay. This is the default value for the argument. So you are defining the function with message equal to hello world string. Okay, this is the default value. Next time when you call this function and you don't pass any argument, so this default argument will take and run it. Okay, that is what the meaning of default. So this is the default value for the argument. They are then followed by an indented code block. So in the code block, what we are doing, whatever message I am taking, I am concatenating with an exclamation mark and assigning it to another variable called text, and then I am returning text. So basically, if I call this function with some argument, let's say my name Madhu, then it will take message equal to Madhu, then it will return after running this function Madhu with an exclamation. That is how this function will work. So if you are making a call to this function without any passing any argument, it will do the default and send the hello world with exclamation mark. So I hope you typed this code. So this is as simple as that. Only thing, from functions point of view, you have to take a pause first. You are doing something, you know that unnecessarily you are repeating too many things again and again. So at that time you have to take a pause and think in your mind, okay, how do I generalize this? What am I doing? So what argument should I pass? Inside that, how do I process those arguments and pass on that to whoever is calling this, so that I can use this named function instead of writing 5-6 lines of code again and again. So that is the way you will use this. Okay. So shall I move forward? Are you able to see my screen and hear me?
Yes, yes, it's
Yes,
done.
Madhu.
Okay. Because sometimes on my computer it's getting muted, so I have to keep checking. And also I'm not looking at this chat box because I'm seeing full screen myself. Okay. Otherwise, also some people know my phone number. They're calling me, so I don't want to be kind of talking to myself. Okay. So far so clear. Okay.
Yes.
Let's move on. So basically, functions are ideal for isolating functionality. They will make it easy. So let's say here, what I am doing, I am defining a function. I'm giving a name square, argument x. Okay. Then colon. So my definition line is done, and then I take a one tab space and writing the logic. Simply, I am squaring it x star x and giving it to output and returning the output. So my function definition is done. I defined another function def cube x. So here x star x and returning output. So I have two functions. Now I am using them in my code. So I'm first line I'm using square 3, so output is 9, then cube 2. So basically I'm calling the function by its name, passing an argument 2 that is being read as x, and whatever inside code it is doing it. And similarly I can use both these functions to provide some good output. So basically you can isolate functionality, it becomes more readable, it becomes more manageable. So that is what your code looks very elegant and clever with functions. That's it. Then let's move on. So optional parts. Let us look at these optional parts, because we talked about an argument, then return, code block, all that. So it's worth noting that the code block is actually optional as long as you have a return statement. You don't need to really write a code block and then return the output. You can just return whatever you want to return when this call happens to this function. That's good enough. No need of code block. Okay, let's here. I'm creating a function def hello underscore world, no arguments. Inside, I'm actually only one statement I'm writing, return hello world. So whenever you call it, it will return hello world. Okay. So similarly, the return statement is optional. You don't need to have a return as long as you have a code block. Okay. So if no return statement is given, the function will return none by default. So you don't need to get anything. You just let's say when you that function is exercised, some action happens and there is no return. So no need actually mandatorily you have to put return. Okay. Here if you look at it, I am defining a function print underscore hello underscore world, no arguments passed, but inside I'm writing one piece of code that is print hello world. So when I call this function, it will just print, exercise that block of the code, because there is a print, it is displayed on my, if you are defining something and you are not printing it, then it will not even show you on the screen, but it would have exercised that code. Okay. So basically the return statement is optional as long as you have code block. Okay. Basically, as long as you have either a code block or a return statement, you are good to go. So both are not needed. But if you want to make it complete and everyone understands it, you can do anyway. Okay. So let us look at the arguments part now. We looked at the code block, and now let us look at the arguments. So functions can have arguments. That is what you are passing at the time of definition, and which are variables that you pass into the function. So once you pass them while definition, inside code block, you can use them as variables. Okay. And then arguments can have also default values set using equal to operator. So here we are defining a function by name print message, and I am passing two arguments, hello world and period, two strings. And then I am actually using some default variable names at the time of definition. The first one I am calling it as message. The second one I am calling it as punctuation. In fact, the functions that we'll use in future while we are doing the project work, they will take many arguments, sometimes 10, 13 arguments also it will take. Okay, so but we don't need to remember all of them, as long as we know what is the named argument. If we know, we don't need to know the order of the 13 or 14 arguments. So let us come to this. So basically here what we are doing, we are defining print underscore message and passing two arguments. One is message equal to string hello world, comma punctuation equal to period. This is the two arguments. So inside the code block, I am using those arguments and creating my output. So I'm concatenating message with punctuation and printing the output. I don't have a return statement here, print output. So when I call this function, okay, without any new arguments, the defaults will be taken and it will print. But if I call with some different arguments, message equal to Madhumurthy, punctuation is equal to exclamation, then it will give Madhumurthy with exclamation. So I'm calling that way. Okay, so let us call that. Let's say I'm using that function now in my program, print underscore message. I'm passing message equal to nice to meet you, punctuation 3 periods. Okay, so it took those arguments and executed the code block with that and then did this. Okay, so to pass a new value for the argument, simply set it again when calling the function. Okay, and like many 10, 12, 13 are there, as long as you know what is the argument name and what you want to pass, if you put that, you don't need to worry in which the position of that argument in that parenthesis, you don't need to carry. Or for that matter, like when passing a value to an argument, you don't have to write the argument's name if the values are in order. Here there are only two are there, so you don't need to always write like this, message equal to punctuation equal to. If you know the order, just pass the values only. No argument equal to value, comma, next argument equal to value. You don't need to write, as long as you know the order. If you don't know the order, like the 10 are there, ninth one is like some max depth in a decision tree. Ninth argument is the max depth, but you don't know first 8, then you don't need to bother. You have to just give max depth and its value. Then other things will be default taken. Only this, whatever value that you are passing, will be taken. So keep that in mind. When we use also, you will understand this. So repeating again, when passing a value to an argument, you don't have to write the argument's name if the values are in order. The first value is for the first argument, second value is for the second argument. Okay, so like this, here we are calling without the named arguments. Okay, so that's about functions, not rocket science. So we'll define these functions. We have to define these functions at times to get our work done faster. Otherwise, unnecessarily we'll be bogged down to write a lot of Python instructions into Jupyter notebook without having to solve our machine learning problem. That's why these will come very handy for you. So keep this much of knowledge about functions in your mind. So we talked about if, elif, else construct. We talked about for construct. We talked about for using it in a comprehension and building very complex transformations on existing lists and single line logic. We have seen that. Now we have seen functions. So now we'll put all this work into our exercise, and I want you to now be in the driver's seat as we do this work. Keep thinking and keep typing the code. Whoever has a comfortable computer and in front of you that you are sitting, but those who don't have, you are listening through mobiles or some such thing, then anyway, try it later. But you have to try it. Then only you will learn this programming things properly. And this is again very basic knowledge that is needed to build models. Okay, that is why I want you to do a little bit of practice. So let us go to our exercise. If you recollect what we did, uh, I sent you four text files of four districts in London with their tourist locations, and I sent a text file, all line separated texts, and then we took the data, read it into our Python system, and we used at that time, again with open file IO. Lot of things are there, but I told you at the time, in Python the best thing is to do with open file IO operations. Very good, actually. We don't need to bother about a lot of things. So we used that, and we read them, and we applied on the text data a Python function called split lines. And when we applied that, converted all those text files into the same names, but lists where these tourist spots were there. Then we looked into that, because lists are sequential objects and we can index them. We looked into that. We checked some membership based on our knowledge of whether that location is in that district or not. To check the data cleanliness, we checked some things using whatever Python knowledge we have. Then what we did is that we wanted to check if any of these locations are redundant. Are there any duplicates? So we used our knowledge of sets and checked for duplicates, and then removed those duplicates, and we cleaned it up. But then we thought, a business analyst came and told us, hey, outer London comprises of these two districts, inner London is comprised of these two districts. So if you organize that way, it will be better. Tourist information system can be provided. So based on that, we pulled all of our lists and created a more clever data structure using a dictionary. And in the dictionary, we created actually four boroughs the way it came from our text file, but duplicates removed. But then we clubbed as inner London and outer London, we created. And we told that once we learn this little bit of this flow and functions, we'll come back to this exercise. But then we wanted to save that whatever final location underscore dictionary object of Python, we wanted to store in our file system as a binary object. So that's where we have used Python's library called Pickle. So we used a Pickle process where we we opened a file with location underscore dict.pickle in WB mode, write in a binary mode, and then we dumped our location underscore dict Python object into that F. Then it was saved. Now from there we'll start and pull back our binary object, read it in a binary mode, and then load it as now again dictionary, and then we start our building logic. Okay, that is what we will do. So in the previous exercise, we created a location dictionary for the boroughs we are interested in visiting. First, let's import our location underscore dict again using Pickle. So you have to import Pickle, then you have to with open this location underscore dot pickle with W, earlier WB, now RB as F. Then we have to now do pickle dot load function. So the F has to be read into a location underscore dict now as a Python object. So this code you have to exercise. So I want you to type it and tell me once you are ready, because you have to get back your this binary object and convert into again location underscore dict, because this is the object on which all the logic will be developed. So please tell me when you are done. Are you able to see the screen?
Yes.
Yeah, yeah.
Okay. So any one of you, if you are ready, that you are able to get back your location underscore dict, let us get back. So are you ready?
Yes.
Okay. So basically, when you have written it last time, if you have not specified any particular path, folder, file structure, it will do wherever you are working on this IPYNB. That's the folder where it will put it. So from there you are reading directly, and you keep remembering what we have done is that we have used pickle.load f, where is basically f has been read from your file system. Last time you gave this name location underscore dot pickle, so that is now into the variable f. That binary object is being loaded, and we are giving it another variable name now, location underscore dict. So we are back with our dictionary object in our Jupyter environment. So let us check whether we got it right or wrong. So let us use first, I want you to do get this output, print the keys in location underscore dict. So last time we have set it up with 4, Satark, Redbridge, Camden, Brent, and then we created outer London, inner London. So basically there are 6 keys in this dictionary. I want to see whether you are actually opening the right dictionary or not. So how do we do that? So it is very simple. We have to
Location dict
use on
dot
the location
keys.
underscore dict dot keys. So if you do this, print your location underscore dict, whatever name you gave, that name, and we know there are keys, values, and items. So here I want to see keys. Okay. And then you will get, so you'll just check that, okay, my dictionary is in order. The same dictionary that I saved, I opened the same dictionary. Nothing is kind of corrupted in this. So everyone got this? Shall I move forward?
Yes, Madhu.
Okay.
Can you
So right
go back
now,
one slide back?
here, this one,
One more back. One more
back or forward?
back.
This one.
Yeah,
Okay.
this one. Pickle.load f. What does that do, Madhu?
So basically, pickle is actually it converts whatever Python objects, okay, like dictionaries and models, whatever, these are all Python objects. We want to store them as binary objects, okay, in the file system, so that we can transfer to anyone. Okay. So also sometimes if somebody passes on to a binary object, then like the binary model or binary dictionary, then you want to convert it as Python object. Okay. So this process is called pickling. Okay. This process is called unpickling. Okay. So basically, last time we, after converting, putting all the data cleaning and everything we did, we wrote a binary object into our file system called location underscore dict dot pickle. Okay. Now using pickle dot dump we did this. Now we are doing pickle dot load. Okay. So because that already that file is there, you last time saved. Okay. You are using with open the file IO instruction of Python, good one. So you have used that file name because already there, and you are opening it with RB argument, means I want to open this file to read in a binary mode, and then you are giving a variable name f. So f contains now location underscore dot pickle in a binary mode. So that is what, after this first one, f is having the binary version of location underscore dot dict dot pickle. Now that binary I want to convert back into the standard Python object. So that is where I'm using the pickle dot load, and I'm passing an argument f. So that process will make open my location underscore dict the way I did it last time. Clear? So this is all called
Yeah.
pickle. So to do that, you have to do import pickle and do that.
Yeah. Okay.
Okay. Fine. So again, why I am talking about that pickle and all, because in the future I'm not covering whole of Python. Honestly speaking, I also don't know whole of Python. I never tried it, but these are all whatever is needed only we are covering, because this pickling is important for us. When we build a model, that model has to be transferred to someone to build an application on that. So this pickle is important. So that is why in exercises those things have been included, just to make you familiar when we do real project. Okay, clear? Can I move forward?
Yeah.
Yes.
Okay, now we established that yes, I have right dictionary, everything. Again, you can do more checks. You can do dot items, dot values, lengths, everything you can check to see that the same dictionary is there. Okay, but anyway, we'll move on. Those are all anyway, you know. Now let us write small logic using our if else logic. Okay, I want to see if inner London list has more locations than outer London list, then I want to print a message. I want to start in inner London. Else if outer London list has more locations than our inner London list, I want to start in outer London. So somebody, a tourist who wants to see more places, so which he wants to start with any location or any place where more locations I can do at a time. Okay, if they're equal, okay, it's fine. Anyway, I can go. So that is the logic I want to build. I want to basically outer London has more than inner London in our locations. Length of, you check that our location underscore dict with our index, that we know that outer London has more. So I need an output like this. So you have to write a logic. So it is not very complex logic. Okay. So basically we have to use a comparison operator, length of location underscore dict inner London with index greater than length of location underscore dict indexed outer London. If that is true, I will start with inner London. Else if, replace this greater than this. Else, okay, that is the kind of thing we have to do. So basically you can write like this. Let me put it here. So I'll put if, oh sorry, anyway it is there, but if length of location underscore dict my inner London. So when I am accessing inner London, location underscore dict, the values, on that values I am putting a length. So it will calculate how many such values are there. Okay. This I have to close here, greater than length of location underscore dict outer London. Okay, again length is there, so I have to close here. So this is my if condition, always ends with my colon. Don't forget that. Then it will go with one tab space. So I want to print. I want to start whatever with inner London. I'm not writing everything. Now, else if you can write and put this first, then greater than this, like that you can write this. Okay. So anyway, I have here, look at it here. So instead of making very complex big sentence to readable things, always we use variables. So here in this we have done whatever length of location underscore, because it's a long thing with a lot of square brackets, parentheses, you make a lot of mistakes and it is less readable. So what we are doing here, all that I am putting here as n number of locations of outer London. So this is the variable I have mentioned, declared and assigned this. The second one is number of locations of inner London. So once these two are set up as locations, the sentences can be more readable. So if number of locations n underscore inner underscore London greater than n underscore outer underscore London, print I want to start with inner London. That is our first thing. Else if n underscore outer underscore London greater than n underscore inner underscore London. Anyway, you can give your own names, but very simple logic. Otherwise, else if they're equal in case, just flip the coin. So did you try it? Did anyone try?
Yeah.
Okay. It is not complex. So, but again, better actually get used to this indexing dictionaries by keys, what happens, and the values can be accessed, and those values length is being calculated, and whatever is that length returned as integer, some value, that value is stored in this variable, and that variable, using those variable names, I'm comparing them to build my conditional logic. It is as simple as that. Okay, shall I move on?
Yes.
Yes.
Yeah.
Okay. Okay, so now let us do a little bit of exercise on our for loop we learned. So for, again, if you remember, we have to think through first what is my iterable, using which I want to loop through each element in that iterable. Then I have to think about a named variable, that every time I am reading one element of that iterable, I am putting it in a name, variable name, and then within the code block I am doing some operations using that named variable, and for every time I loop through the iterable, I calculate something and show it something. So that is how we learned for, and extended that thinking to list comprehensions. We will do that. Okay, so here there is one exercise you have to do. For each key in location underscore dict, print the number of locations in its list. Like I have 6 keys: Satark, Redbridge, Camden, Brent, Inner London, Outer London. So I want to actually print like this. Say it's the first placeholder is Brent, has, let's say I calculate 12 locations. Then Camden has so many locations. Inner London has so many locations. Like that, I want to loop through my dictionary and summary of the dictionary with respect to what is the borough name and how many locations to visit, kind of thing I want to print. Okay, so we have to use a for loop. What is the iterable for our for loop? Basically, we have to this is the output I want to get. So let us do for some name we have to look at it, locations. Okay. So first let us think about what is my iterable. Iterable is because I want to do location, everything I need to do, both keys and values. Location underscore dict, because key will have my name of my district, value will have my length of that list. Okay, so I am, or actually not length of the list, all the items, elements in that list, names basically. So I will apply for my iterable items. Okay, this is my iterable. Basically when I run this, it will give keys and the values for that key in a, actually it actually gives an output as a list, but it is a list of tuples, keys and value pairs. That is what it gives. That is my iterable. I want to go through that iterable because I want to print this kind of output. I want to have a key name, and also I have to length of the values also I want to know. So basically items will return both keys and values. So I'll name them like that only, for key comma value in. Okay, this is my for loop for named variable key comma, any named variables can be one or more also. For key comma value in location underscore dict dot items, that is my iterable. This is my for loop. So it will go through every item in my dictionary. Okay, I'm putting a colon here, and with a tab space I have to get this. So basically I can print. Okay, again hint is already given to me, so I want to use placeholders. So I want to get one first placeholder, I want to get the key. Okay, and has again a placeholder where I want to get the number, length of the list, value list. Okay, then locations. This is my string I want to print. So this I will start with a single quote here, end with a single quote, and then I apply dot format on my string. Okay, and in the dot format I am putting first placeholder as to get my key. Okay, it is reading in this dictionary, iterating through that. So key, if I put that, it will get the first value in my first braces there. What I should get for the second placeholder? Second placeholder, I want to get length, not the values, but length of value. Okay. Then anyway, I have to properly close. This is dot format parenthesis. This is my print parenthesis. So many, whatever parentheses are there, properly I have to close. And I think this will produce the desired result for your location dict. 6 keys are there, and you are calculating locations. So let us look at it. So please write this and look at it. So that you are thinking through loops. So basically whenever this kind of thing, I have to iterate through a dictionary object and create a summary of what is there in the dictionary, what summary I want. If that is in your mind very clearly, then you have to set the iterable, and you have to also think about the variable, named variables. Then put that for named variables in iterable colon, then think through what has to be done, what output I have to generate, and then based on that you can do that. So did you accomplish this?
Yes, sir.
Okay, so only it's based on your context and situation, you have to think like that. Okay, so for loop exercise we have done. Now let us do little bit more complex one. Okay, this is a little complex where little bit more Python knowledge we have to develop, because we wanted to build a tourist information system. Okay, different people with different interests will be there. Okay, so in this exercise, what we want to do, using our dictionary object, we have all the boroughs and the tourist place names are there in that lists. So if you look at previously, Tatark has 13, Redbridge has 16, with a lot of names. If you look at it, values, you will see all that. Inner London, Outer London has 35, 32, all these things. Now somebody is interested. Some people are interested in visiting some pleasant locations where there are farms or parks or hills or something green. They are more interested. But some people who really go to London, they are more fascinated by the grand locations, like the royal, queen, king kind of location names are there. At least a substring in the location name reflects royal or queen or king. They sound like they're royal places. And farm, park, hill, green, these are like more pleasant places. So I want to provide to my tourist some information. Let's say my preference is to go and visit pleasant locations. So what are the pleasant locations in inner London? Or I want to see royal locations. So how many locations or what locations are there in outer London? That kind of thing I want to see that. Okay, so that is what really we are building. So basically what we want to do is that we want to use both if and for. We are using loops and the conditional logic together. And if any location's name has this substring farm, park, hill, green, any of these four of these things are there, then that location sounds pleasant. That is what you have to print. Else if it is not, check with these substrings, royal, queen, king. Then you print that name of the location sounds grand. Okay, if it doesn't sound, either means if it doesn't have these four substrings or these four strings, then it doesn't have any of the things. So just ignore them, don't worry about it. Okay, so to do this, anyway, if and for we have to use, but there is one more built-in Python function, any is there. Any basically what it does is that if any basically works like this. Oh, sorry. Any, you can pass an iterable here. Okay, this iterable have a lot of elements. These elements, let's say true, some four elements are there: true, false, true, false. Okay, so if we pass any with this iterable consisting of true, false, true, false, any one true is there, it will return true. If all of them are false, then only it will return false. Okay, so that kind of logic it gives you, which will be useful in this exercise. That's why we are talking, but you can read more about this. And then there is another thing called all also, all and an iterable. So people use that. Okay, so we will be using all of that to get this kind of output. Okay, so as an exercise, I want you to get this output. Okay, so pleasant. So basically to do this, what we are doing is that we are setting up these two lists, because these words, substring words, I want to test in my each location. Okay, so let us think about it. How do we build this logic? This is a little bit complex logic. Okay, let us think about it. So I am first putting these two things together. One set of substrings in my exercise, I am calling it as pleasant underscore sounding. Second one, I am calling it as royal underscore sounding. Okay, so I am setting up two lists to use them to check every location name. So my exercise I have to do is at outer London. Okay, I have to actually, for each location in outer London, I think outer London has how many? Let us look at it. Outer London has 35 locations. For each of these 35 locations, I want to iterate from the first one to the 35th one, and I want to check for pleasant thing. Okay, I can check for royal also, but let us check for pleasant one first. Okay, so so basically I have to take the first location name of the 35 and check for form first. If form is there, I will put a true. Then I will also check for park. I will check for hill. I will check for green and create true, false, whatever that. And any I apply. And if at least one true is there, then I will write a if statement and print like this. Brent Park sounds pleasant because it has park. Okay. Or Dollis Hill sounds pleasant because it has hill. So let us put for the pleasant sounding in outer London we want to create. So anyway, two lists we have created, pleasant sounding. Anyway, now that we have to use as a inner loop. So first we have to put a for loop at the outer side. What is my for? I have to use my location underscore dict as an iterable, but I want to get all location names in my outer London. Okay, this is my iterable. All those 35 location names strings are my iterable. I created that iterable here, big one, some name, comma, like that, 35, 1 to 35. Okay, but what is my named variable I will give? So let us call it as a location name, or let us say for name, simply we'll call it as name. Name is basically name of the location. Okay, again for will be requiring this keyword in. So I am setting up my outer for loop for name in location underscore dict indexed, because I'm only interested right now on values of outer London key. Clear? So it has 35. So I set up my iterable with all the location names. So now basically this for what it does, it picks up the first one and I want to do some action. Okay. So what action I want to do for the first one? Ultimately, I want to produce Brent Park sounds pleasant. So I have to write some logic here. Anyway, I need to put my colon with a tab space. So I have to put some if condition. What is my if really? If any of these words, farm, park, hill, green, that is there in a list called pleasant sounding list. I want, so basically I need to set up a one inner for loop in which I want to like that basically word, every word in pleasant sounding is my one iterable. Okay, so farm, park, hill, green, whether that is there in this or not, I want to check. Then I will go next and check whether the second one again, farm, park, hill, green is there. Any one of them is true. I want to print that pleasant. Otherwise, I don't want to print anything. Okay, so I want to iterate through this farm, park, hill, green for every location I chose. So inner loop also I'm thinking. How I'm thinking, how we should think. Anyway, I have an advantage of knowing the code. But what I'm really trying to do is that I want you to think through these things, because ultimately you have to build some logic for your own context later. So I want to, so this basically will return in the within the loop. First it will start with form, word will get form, and let's say this is Brent Park. Okay, first one is Brent Park. Okay, name is in Brent Park, so word is form. So now I want to check whether this word is in Brent Park or not. Okay. So how do I check? So I have to check that. Let me write this if little here. I will not write here. I may need space. So word in present sounding. So what I want to do is that I want to check word. This is membership. Word in name. It will, in is a keyword. Word in name. If the word is there, let's say in Brent Park form is there, it will result in true. In Brent Park form substring is not there, it will return false. Okay. So I will see that word in name. Okay. I want to check for every word here. Okay. So that is what I want to happen. And when I do this, it will go through all the four and it will give either four true or false values. So now I have to apply to this any. So any one is true, get me that. Okay. If any word in name for, okay, any word in name, again this for loop I am putting it, for word in pleasant sounding, okay, for this looping, check any word is in the name, okay, and put a if here. This is in a tab actually. Then print whatever the name of the location, that is the first argument of print, then comma sounds pleasant. Okay. So else if you can write whatever, but to do this only pleasant, you can do this. So basically I'm setting up an outer for loop, and then I am building an inner for loop for word in pleasant sounding words, and I'm using word in name, that membership check, which is producing, because there are four, either true, comma false, comma false, comma true for each one of these one form park. Then in that I am making it whether it is any one is true, it will be true and it will execute. If the false is there, it will come out, it will not execute this statement. Hope the logic I'm trying to build is correct. Any questions? But anyway, let us type this code and see for yourself. Okay. So are you there?
Yeah, Madhu.
Yes, yes.
Yeah.
So
Yeah.
these are little bit complex logic, but try to understand. So pleasant sounding, we have created a list based on the exercise. Royal sounding, another list we created. So we are setting up a higher level for loop because we want to go through each of those 35 locations of outer London names. We have set this loop. Then within that, we are writing some conditional logic. So while writing conditional logic, we are everything, every word in pleasant sounding, we want to check whether this is a substring of the name of the outer London. So for that, we created within the if a very complex word in name. It will check for true or false whether that word is in name. But we are going iterating through this word. How many ever words are there? In the first one, pleasant sounding, 4 are there. So I'll iterate for 4 times, and I create whether true or false 4 of them. Then any true is there, then I will go and execute the after if the true condition. I will put sounds pleasant. If it is not there, I can write a elif, and here only between elif thing is that I am here checking for royal sounding. I will check for royal, queen, king. Then it will check for that and it prints the name sounds grand. Okay. So any of you typed this code? So while doing this, keep remembering the semicolons, tab spaces, whatever right kind of operators, parenthesis, closed, open, then you will be coming in. Think about this logic once. So anybody done this?
Yeah.
Okay. So if you have to understand a little bit better also, then you check for this any may be confusing here. So check that what it does really. Okay. So that is how we can build loops, within loops conditions, within the conditions again put loops and build some binary comparisons and use this any all to do all these complex things. Okay, so the same thing let us do with list comprehension. Okay, so already you have pleasant sounding. Instead of writing so many lines of code, why don't we write in a simple list comprehension, which we have learned. Okay, so we want to get this output. So you know what is the list comprehension now. So let me again repeat that. List comprehension, we have to think about an output. Okay, so finally this output has to be created. That will start first, then followed by a for loop. Then whatever that for iterable element is there, on that iterable we have to put some logic using conditional and further fors, whatever. So whatever we have done, we can create one simple list comprehension. So list comprehension, how we will do? We will define starting with square brackets. So we have to think about the output first. My output is actually name of the location, name. Okay. Then my loop is actually for name in my location underscore dict. Let's say we are doing for outer London. Okay, pleasant sounding for outer London. So that is what I'll put my iterable. Okay, so name, my list, my for loop is here for name in location underscore dict outer London. Okay, whatever I do that will come as an output and a list will be appended. That is what is the list comprehension. But then I want to apply some conditional logic here, because I want to create a pleasant sounding list, location list actually, like whatever in the seeing here. Okay, so for each of the 35 locations, I will take again if any, okay, word in name for word in pleasant sounding. Okay, so if I put all this into a single list comprehension, whatever that code we wrote, it creates one pleasant sounding locations list. Okay, so that's what happens. If I change here pleasant sounding to royal sounding, then it will give royal sounding of location outer dictionary, outer London thing. Okay, same thing we are doing but using comprehension. So you can look at here. So pleasant underscore locations. So name, that is my output. Outer loop I'm putting for name in location underscore dict outer London. Then on each of those element in this iterable, I am applying if any, again word in name. This is my, it will return either true or false for this loop, word in name. So again it iterates through the inner this pleasant sounding list, and because any is there, any one true is there, it will put that name only here, this name, and this name is appended to your pleasant locations. Clear? Anybody typed this? So whatever that logic we have built, outer loop, inner if with inner for loop with this other list, all these things have been put into one single expression, and we are calling it as a list comprehension. Okay, anybody type this code? Okay, please do that and let me know once you are ready. So this name is the output of my list comprehension. This is my external loop where I'm looping through my all locations of outer London. So first location will get the name, variable name will store that. Then for that element, I am doing if any word actually comes from this pleasant sounding, let's say it's a farm, first one. So whether farm in Brent Park, okay, then farm in Brent Park is false, so it will put false. Then it will go and look at farm in some other thing, green farm, for true. Then third one is also there, farm in Royal Garden, false. Okay, then that FTF list will be checked with any, because one is true, it will return true. So true, so true, that will get name output. Then that output will be appended. Same thing in the other logic, it will happen here. Got it?
Yes.
Any one of you without any error typed it?
Yeah.
Yeah. So anyway, I want you to type it, get the results, then reflect on the logic, what we did. Many ways we can write also. We can write it in many lines by dividing all these things. First create this false, true, false kind of list, then apply any on that. Before that, read it and create that list. All these things we can done, but we are compressing and thinking the problem in our mind using some English language and trying to put that English language into Python. That is the idea we are trying to do. Okay. Shall I move?
Yes.
Okay, you can do create royal locations by putting the second word list, whichever way you want to do, you can do. Okay, so print the number of pleasant sounding locations. So whatever pleasant locations, this is the list comprehension with it. So length of this you do, then you will get 9 locations are there in outer London, which are actually sounding like they are pleasant. Okay, then let us apply the same thing very quickly to functions. So basically what we are doing, we have a set of pleasant sounding words, we have some royal sounding words, and we are searching through these words in our location names of inner London, outer London, and putting them. This has this, like that, so that tourists can choose based on their preference. So we are doing same things. So why to write all these for loops and all? Write a function in a very simple way, because what really we are doing is that filter locations. Okay, you are filtering locations by some districts and each district, and then with some particular word strings. So pass 2 arguments and build that. Okay, write a function called filter underscore locations that takes 2 arguments. First argument is location underscore list. Okay, like your location underscore dict outer London, inner London, Camden, these are all location lists. You can pass anything. You don't need to write again and again for one of the districts. So if you have a function, just you have to call the function with a different location underscore list, and then words list. Now you have 2 word list. One is royal sounding, another is pleasant sounding. You can create some more thing. Okay, but we are solving this whole coding problem cleverly by writing a function. Okay, so the function is as good as this. So I'm defining a function def calling it as filter underscore locations. Okay, whatever name I can give. Then I am passing two arguments. First argument is location underscore list. Okay, the second argument is words underscore list. Okay, colon. Okay, and I'm writing one return statement. In that return, I'm just returning a list comprehension. Okay, so anyway, the list comprehension, anyway, we have done name for name in location underscore list. So name is the output of your list comprehension. This is your location list iterable, and one element you are picking up here one by one. Then on that one, first one, you are applying if and checking for any of these words list is there. Then if it is true, you are returning it to name. If it is false, you are ignoring. Like that, you will go, and finally a list will be returned here. You can call this function with right arguments and it will return a list to you. You can save that list and you can do whatever you want to do. Okay, so basically this is my function we have defined. Let us call this function now. Okay, to create present locations using filter locations. So we have to call this. How do I call? I want to do it for outer London. So my location underscore list will be location underscore dict outer London. My word list will be pleasant sounding words. Okay, I pass it. So here I'm calling the function filter underscore locations. So first argument I'm passing as location underscore dict outer London, comma. The second argument is my word list, that is pleasant sounding I gave. Then we know it will return because we have put a list comprehension there. It will return this, and I am putting it to a pleasant location list. Now if we want to do royal list locations, then call this filter underscore location underscore dict outer London. You change this argument, royal sounding. Or you want to do it for Camden, then pleasant locations in Camden. So pleasant locations, whatever Camden, filter locations underscore dict Camden here, and give pleasant sounding. So you can use this function to get for all 6 districts all this information. Okay, pleasant, royal, so that tourist information can be built in a proper way. Did you type this? Did anyone try this?
It is saying
First, you have
filter
to,
locations, not.
this is the no filter underscore locations is the name you are giving. You have to give def, and colon has to be there. This is your name. You can give any name. In this snippet, we have given filter underscore locations, but you can give any name. But you have to, while making a call it the way you gave it. You cannot give it like, say there you gave location, here you are calling locations, yes, locations, then it will tell. Those kind of things only you will be making mistakes.
Yeah.
Got it? So first define the function and make the function call with whatever arguments you want to give, and you can try with that. Got it? Can I move forward? Anybody typed it and got the answer? Please let me know. Are you
Still
able to
trying.
hear me? Yeah. Still trying. Okay. So anyway, carefully type this. So basically here we are defining a function. Okay. This is the name I gave, and these are the arguments. Again, you can give in any way, but this is what we gave. Then inside that we are using these arguments. So the location underscore list. We have to get it, because in the previously we wrote location underscore dict with outer London. All that I have removed and made location list now here. Okay, here. Then pleasant sounding, we told that we have put it as words list now. Otherwise, rest of the things is the same. Okay. Shall I move forward?
Yeah.
Anyone got
Madhu,
it
I am getting
successfully?
invalid syntax only.
Okay. Which one? The first one, definition of your
Yeah,
function?
this one. Yeah, definition of filter underscore function.
Okay. So carefully look at it. Def has to be there. Name, then parenthesis, then this location underscore list, word underscore list. I gave it like that, but you can give anything. This colon is very important. Okay. Then return square brackets, because it's a list comprehension. You have to open a square brackets. Then this is the output that will be produced in the list comprehension. Then there is a for loop from here to for name in location underscore list, because that is what we are using here. Okay, the argument. So if the argument is some different, then it may tell. Then if any brackets are opening here, word in name for word in words underscore list. So look at it. Maybe type it the same way. You should not have any problem. Okay. Any one person got it?
Yeah.
Okay. Anyway, you can try it. You may be typing something not correctly. That's it. Actually, in Python, that is the only thing will happen. Otherwise, nothing, no big mistakes. Okay.
Okay.
Once you set up your function very well, then you create pleasant underscore locations for Camden, all 6 of them. Then royal locations. You can call this function, pass the right argument. Okay. Here, if it is inner London, you have to change inner London. If you want royal sounding, if whatever name you have given, royal sounding, that you have to put it here. That's it. You will get all the output. Okay. So basically here we are doing both the grand sounding and grand locations using all these filters. We have done it grand locations, pleasant locations. We use this function and got it for outer London. So sometimes if you look at the Queen's Park, okay, Kingsbury, Park Royal have actually Kingsbury only having king. This is royal, but Queen's Park has both pleasant word substring and royal substring. Similarly, Park Royal also has both. Okay, so your pleasant locations and your royal locations list that is filtered using this function may have some common elements because of the way the names are sounding. If you look at here, okay, here Kingsbury, Queen's Park, Park Royal, these are the grand sounding locations. Brent Park, at least if you look at Queen's Park is here also. Okay, Queen's Park is here also. Okay, so both location because of the name. So in case you want to find out what are those common things, both pleasant and grand, then anyway you have these 2 lists. Okay, pleasant location list is there, grand location list is there. You want to find the common of them, first convert them as sets and you do an intersection operation of the 2 sets. Then you know that there are 2 places common in both pleasant locations and grand locations of your outer London. One is Park Royal, second one is Queen's Park. So we can do all these things. So that's it. So any questions you have? Are you finding it very complex?
Little complex, but yeah.
Logic, again, even this kind of complex logic also we will not write while we are writing your code. This is just to create some exercises. Okay. So with this, we have covered the basics of Python, data structures of Python, flows and functions of Python. Now, the most important for our projects is two data science libraries of Python. First one is NumPy and the second one is Pandas. Again, we will spend learning about NumPy and doing an exercise with NumPy. Then again, learning Pandas and doing an exercise with Pandas. With that, our Python crash course for data science will be over. Then we will start our project. Actually, I don't know how many of you are really trying the code as we are talking. Maybe I'll figure out a way to do some polling in the GTM. I think we can do. I'm not using all the features of GTM, but otherwise also in mails you can tell whether you are doing exercise or not. Then whatever you do hands-on, it will be good. Any questions?
Madhu, can you just go to the definition of location underscore that is filter locations you created, right? So
yeah,
I'm just getting a syntax. Yeah, this one.
Yeah.
Okay. Just because
okay, what
when I
syntax error you did?
It is giving me indented indentation error, expected an indented block.
Colon has to be there. After that, one tab space has to be there. That is a must. Then anyway, again, sometimes whatever error comes, you have to go to that line and see.
Yeah. I'll check that. Yeah, thank you.
Okay. Fine. Okay. So that's it for today then. Hope you are able to learn, not getting too much bored. Okay. So if there are no further questions, we will close here and have a wonderful day. Learn, have fun. Bye-bye.
Thank you, Madhu.
Thank you.
Thank you.